Every tap, every swipe, every notification on your Android device, they all flow through one process. Process ID 723, user system, parent 347. That's Zygote from episode 11. 246 services running in this one process, that is system server. The single most important process in Android after Zygote. Without it, there is no activity manager to launch apps. There is no package manager to install APKs. No window manager to show anything on screen. No Android. In episode 11, we learned that Zygote is the parent of all apps. Today we are diving into Zygote's first child, the one that makes everything else possible. Welcome back to Android Internals from Scratch. We are from Must Electronics. If you have been following this series from episode 1, we have come a long way. We have downloaded AOSP, built Android from source, flashed it to the Raspberry Pi 4, and in the last 3 episodes, we have been systematically understanding how Android boots and how processors work. Let me quickly recap episode 9, 10, and 11 because today's episode builds directly on them. In episode 9, we learned the 6-stage boot sequence. Stage 1, bootloader loads the kernel. Stage 2, kernel starts init as PID1. Stage 3, init starts Zygote. Stage 4, Zygote preloads framework and forks system server. Stage 5, system server starts all Android services. Stage 6, launcher shows the home screen. Today we are doing a deep dive into stage 5, that is system server. In episode 10, we learned that init is PID1, the parent of all processes, and it starts services defined in init.rc files. One of those services is Zygote. In episode 11, we learned that Zygote preloads 17,182 framework classes, then forks child processes. Apps inherit all that preloaded code instantly via copy on write. Zygote's first child is System Server. Today we are answering these questions. What exactly is System Server? What does it do during boot? How does it start 246 services? How do apps talk to these services? And most importantly, let's see it all in the source code and watch it happen live in this Raspberry Pi. By the end of this episode, you will understand the process that orchestrates everything in Android. Let's start by looking at it in the running system. So, what is System Server? Let me give you the conceptual answer first, then we will see it in code. System Server is where Android lives. When you call start activity, you are talking to Activity Manager service inside System Server. When you install an APK, that's Package Manager service inside System Server. When a window appears on screen, that's Window Manager service inside System Server. All of these run as threads inside a single process. They don't run in separate processes. They share memory inside System Server. Here is how apps talk to these services. Apps use inter-process communication to talk to System Server. When your app calls start activity, that call goes through IPC to Activity Manager service running inside System Server. We will explore how this communication works in upcoming episodes. System Server is also responsible for boot phases. Android doesn't just dump all services at once. There's an order. Services register for these phases and get callbacks. This way, Window Manager can wait for the display, Package Manager can wait for the storage, and apps don't launch until everything is ready. Alright, enough theory. Let's see System Server running on our Raspberry Pi, then we will dive into the source code. Let's inspect System Server on our Raspberry Pi 4. First, let's confirm it's running. There it is, PID 723. Look at that memory usage. 21 gigabytes of virtual address space, 334 megabytes resident in RAM. This is a huge process compared to a typical app which uses 50 to 100 MB. That's because it hosts 246 services. Each line has a service name on the left, like activity, package, audio, and the interfaces in the brackets. Apps look up services by name using Service Manager. Let's check if a specific service exists. Found. That's Activity Manager service. Let's try a fake service. Not found. So the service list is the registry of everything available. Now let's actually talk to a service. I'll use dumsys to query Activity Manager service. This is Activity Manager service internal state. Dumsys queries the service and asks it to dump its configuration. Every service implements this dump method for debugging. Package Manager service. This service tracks every installed app, their permissions, their components, everything about APKs. Window Manager service manages all windows and displays. So we have confirmed system server is running. It hosts 246 services and we can talk to those services via dumsys. Now let's see how this process starts. Let's look at the source code. Let's open SystemServer.java. This is the entry point. 154 kilobytes. Let's check the line count. 3499 lines. This is not a small class. Let's open it. At the top, look at these imports. Over 200 import statements. This class touches everything in Android. Here's the class definition. It implements dumpable, that means it can dump its state via dumsys. Now let's find the entry point. Remember from episode 11, Zygote forks system server and calls its main method. Here it is. Simple. Create a new system server instance and call run. All the real work is in run. Let's look at that. Here is run. This is the method that starts Android. Let me walk through it step by step. First section. Set system properties. Configure the time zone. And set up internal communication settings. Step 1. Prepare the main looper. This is Android's message queue. Services will post messages to this looper and it processes them one by one. This is the event loop that runs forever. Step 2. Load native libraries. Some services need native code. This loads Android servers.so, which contains JNI implementations. Step 3. Create the system context. Every Android component needs a context. Apps have application context, system server has system context. Step 4. Create System Service Manager. This is the class that actually starts all the services. System Server delegates the heavy lifting to System Service Manager. Step 5. Start services in 3 batches. Bootstrap, Core, and Other. This is the order that matters. Bootstrap services start first because everything else depends on them. Step 6. Start looping. Looper.loop is an infinite loop that processes messages from message queue. It never returns. If it does, something catastrophic happened. So we throw a running exception. That's the run method. 6 steps. Configure settings, prepare the looper, load native libraries, create system context, create system service manager, start services in 3 batches, then loop forever. Now let's see what gets started in those 3 batches. Let's look at start bootstrap services first. Bootstrap services. Installer, Activity Manager, Power Manager, Package Manager, User Manager. These are critical. Without Activity Manager, you can't launch apps. Without Package Manager, you can't read installed packages. Without Power Manager, you can't manage the display. Let's see core services. Battery service, usage stat service, WebView update service. Not absolutely essential for boot, but needed early. And now the big one, start other services. This method is 1500 lines long. It starts over 200 services. Input manager, window manager, Bluetooth, connectivity, all the services that make Android functional. Everyone gets started here. So that's how services are started. But how do they get registered so apps can find them? That's done through Service Manager. Let's look at that. When a service starts, it registers itself with Service Manager. Service Manager is the global registry. It's like a phone book for services. These services are registered with names, activity, and activity task. Let's see where that happens in code. Here's where Activity Manager gets registered. Context.activityService is a constant. Let's check what it is. It's the string activity. So this line registers Activity Manager service with the name activity. And that's why we see it in service list. The process works like this. When an app wants to start an activity, it looks up activity from Service Manager, gets a reference to Activity Manager service, and makes the call to it. Let me demonstrate this. I am going to query Activity Manager service using dumsys. This dumsys command is doing exactly what apps do. It looks up activity from Service Manager, gets the reference, and queries the service. Same thing with Package Manager. All service access goes through Service Manager. So now we know how services are started and registered. But we still haven't seen how Zygote forks system server in the first place. Let's trace that. Remember from episode 11, Zygote init.main does three things: preload, fork system server, and then listen for app launch requests. Let's focus on step 2, forking system server. Here's the fork system server method in Zygote init.java. Look at these arguments. This is what Zygote passes to fork when creating system server. UID 1000 is the system user. That's why when we ran PS, we saw system in the user column. Here's the fork call. Zygote.forkSystemServer is an AT method. It calls down into C++ via JNI and actually does the fork system call. After forking, we check the return value. If PID is 0, we are in child process. That's system server. If PID is non-zero, we are still in the parent. That's Zygote. In the child, we call handle system server process, which eventually invokes SystemServer.main. Let's verify this in the running system. There it is. System server PID 723, parent 347. User is system, which is UID 1000. Exactly what the fork argument specified. Notice, there are actually two Zygote processes. Zygote 64 for 64-bit apps and Zygote for 32-bit. System server was forked from Zygote 64. So that's how it starts. Zygote forks with specific arguments. The child becomes system server and the system server.main runs. Now let's see this happen during boot. I have restarted Raspberry Pi. I am going to show you system server's boot logs from the current boot. As we restarted Raspberry Pi, the PID of system server changed to 732. Watch the sequence. Enter the Android system server, then start Bootstrap services with timing information for each service. System server logs everything it's doing with precise timestamps. Boot phase logs may have rotated out of the locket buffer. In a fresh boot recording, as we did now, we would see phase progression from 0 to 100, 100 to 500, 500 to 600, 600 to 1000. For now, let's look at how phases work in code. These logs show us system server starting during boot. Let's understand the boot phase mechanism. Boot phases are defined in SystemService.java. Let's open it. Integer constants 100, 480, 500, 550, 600, 1000. System server advances through these phases during boot. For every registered service, call its onboard phase callback with the current phase number. Services override onboard phase to react to different stages. Let's see how Activity Manager service uses boot phases. Activity Manager service reacts to three phases. System services ready at 500, Activity Manager ready at 550, and third-party apps can start at 600. Each phase triggers different initialization steps. This is how Android's boot is orchestrated. Services don't just start randomly, they coordinate through phases. Display must be ready before Window Manager starts. Storage must be ready before Package Manager scans apps. Everything has an order. Let's interact with these services live. Let's interact with System Server services. I'll show you some useful commands for debugging and understanding how services work. 247 lines, 246 services plus the header. Let's check a specific one. Power Manager service is running. Let's query its state. Display Power Object reference. Now let's do something interactive. Launch an app and watch Activity Manager service handle it. First, let me stop Settings app. Let me clear Locket. Now I'll launch Settings app. The AM command stands for Activity Manager. This is a command line tool that talks to Activity Manager service. Let's see what happened in the logs. Activity Manager service logged the start. It created a new process, PID 2549, and launched the settings activity inside it. Let's verify that process exists. There it is, PID 2549, parent 1162. Zygote forked it. In the start of the video, Zygote PID was 347. As we restarted, PID got changed. This is how apps launch. Activity Manager service inside System Server coordinates with Zygote to fork a new process, then starts the activity. This shows activity state. Currently launcher is on top. All of this state is managed by Activity Manager service inside System Server. So that's System Server. 246 services, one process coordinating everything. Let me wrap this up. Let's recap what we learned today. System Server is the heart of Android. When you tap an app icon, Activity Manager Service starts it. When you install an APK, Package Manager Service handles it. When you see a notification, Notification Manager Service created it. Everything flows through System Server. Let's connect this to the full boot sequence we learned in episode 9. We now understand the first 5 stages of Android boot. We know how init starts, how Zygote preloads and forks, and how System Server orchestrates the framework. But we have been mentioning these services: Activity Manager Service, Package Manager Service, Window Manager Service, without really diving into what they do. How do they actually work? What makes each of them special? In episode 13, we are diving deep into Android Framework Services. We will explore Activity Manager Service, Package Manager Service, Window Manager Service, and others. We will understand what each service does, how they interact, and we will use dumsys to inspect their internal state. We will see how launching an app involves multiple services working together. Before next episode, I want you to explore. Pick 5 services from the service list, maybe audio, Bluetooth, location, alarm, notification. Run dump sys on them, see their state, then find where they are started in SystemServer.java. Get familiar with the code. That's episode 12. We have covered a lot. 3499 lines of SystemServer.java, 246 services, boot phases, service registration, and live system interaction. If you are still with me, you are building deep Android knowledge that most engineers never reach. We built this Android system from source. We are running it on real hardware, and we are understanding it at a level that only AOSP developers typically see. This is the real stuff. If you have questions, drop them in the comments. We'll read everyone. If this video is useful, please like the video and subscribe to Must Electronics.